in this class, we are going to write the two forms of rate law expression. Remember, there are two methods of writing the rate law expression. The first method is the one we call the differential method, while the second one is the one we call the integrated rate law expression. The differential rate law expression is the expression or the formula that shows the relationship between the rate of a chemical reaction and the concentration. The formula that shows the relationship between the rate of a chemical reaction and the concentration is known as the differential rate law. While the formula that shows the relationship between the concentration and time is the one we call the integrated rate law expression. So, for first order reaction, remember we have what we call the first order reaction, the second order reaction, the third order reaction, and so on. We also have what we call the zero order reaction. Now note this, a zero order reaction is a reaction whose rate does not depend on the concentration of the reactants. A first order reaction is a reaction whose rate depends only on one reactant. A second order reaction is a reaction whose rate depends on two reactants. Now, for the zero order reaction, our rate is equal to, note this, generally for differential equations, for differential, rate is equal to rate constant multiplied by concentration. So, the power of the concentration is what will now tell you the order of the reaction. For zero order reactions, in the differential equation for zero order, we have that rate is equal to rate constant multiplied by concentration of the reactant. Here, I'm using A to represent my reactant. So this thing simply means concentration of A. Now, my rate is equal to rate constant times concentration. This is the general formula for the rate of reaction. Now, the power of my concentration tells us the order of this reaction. Since we are talking about zero order, the concentration will bear the power of 0. And you know that anything raised to power 0 is equal to 1, just like saying 5 raised to power 0 is equal to 1. So, A raised to power 0 is equal to 1. Anything raised to power 0 gives us 1. Therefore, simply means that this place, the whole of this stands for 1. And 1 times K is K. So for zero order, we have that rate of reaction is equal to K. And remember, K stands for rate constant. As you can see, for a zero order reaction, rate is equal to the rate constant for a zero order. Why? Because the rate of a zero order reaction does not depend on concentration. And that's why the concentration here has the power of 0. This one here is the differential equation for zero order. But the integrated rate law for zero order says that, remember, the integrated rate law is the equation that shows relationship between concentration and time. So, the integrated law or formula for zero order says that initial concentration, which is A0, minus final concentration, which we call AT, is equal to rate constant multiplied by time. This is the formula, the integrated rate law formula for zero order. Why this is the differential formula for zero order. The differential formula is the one that shows relationship between rate of the reaction and concentration. While the integrated expression is the one that shows the relationship between concentration and time. A0 here stands for initial concentration, AT stands for final concentration, K stands for rate constant. Now, For zero order reaction, half-life, which is T half, is equal to initial concentration, which is A naught, divided by 2 times K. This is the formula for the half-life of a zero order reaction. The half-life of a zero order reaction is A naught, which is initial concentration, divided by 2 times rate constant. Now, when you plot the graph of initial concentration, that is A naught, against time, when you plot the graph of initial concentration against time for zero order, note that the slope is equal to negative K. The slope of a zero order reaction is equal to minus K. That is for zero order. Now let's go to first order. The differential rate law equation says that rate is equal to rate constant times concentration raised to power 1. Remember, first order, so the concentration is raised to the power of 1. While the integrated formula says that ln of the initial concentration, that is natural log of initial concentration minus natural log of final concentration, is equal to K times time. The difference between the integrated formula for zero order and first order is nothing else but the use of ln, the natural log. And for the first order reaction, as you can see, the half-life for first order, the half-life is the same half-life you have for radioactivity, which is ln 2 divided by K. And if you punch ln 2 in your calculator, you have it as 0.693 all over K. This is the formula for half-life of first order reaction. And when you plot the graph of ln of initial concentration against time for first order, your slope will still be equal to negative K, just as in the zero order. Now the last one we are going to talk about here is the second order. For second order reaction, our rate is equal to rate constant times concentration raised to the power of 2. Or we can represent, if I have 2 reactants, if I have only 1 reactant, I'll raise to the power 2. But if I have 2 reactants for second order, I will say rate is equal to K times concentration of the first reactant, which is A, to power 1, times concentration of second reactant, which is B, to power 1. So that 1 plus 1 will still give me 2. Now my integrated rate law expression is, for second order, says 1 divided by final concentration, which is AT. In second order, final concentration starts, but in zero order and first order, initial starts. So 1 over AT, that is final concentration, minus 1 over initial concentration is equal to KT. This is for second order integrated rate law. And for second order, the half-life for second order reaction, the half-life, which is T half, is equal to 1 all over K times initial concentration. This is the formula for the half-life of second order. And when you plot the graph for second order, if you plot the graph of 1 over initial concentration against time, you discover that your slope will be equal to the rate constant K. That is for second order. Thank you for watching. Do not forget to share this video with your friends and subscribe to our channel. Thank you.